Basic residential construction. In front of you, I gave you a copy of all the slides that's going to be putting up so you can follow along with me. In this chapter, basic residential construction, learn objectives. Recognize basic architectural types, styles of residential construction. Identify the basic components of a house, foundation, and the frame. Describe the basic elements of construction. Explain the provisions of the North Carolina Residential Building Code, HUD standards, and the North Carolina General Contractor License as far as using that and what's required as far as having that. Licensees, that's you, should possess elementary knowledge of basic house construction. Construction principles, techniques, terminology, obviously it's going to help you. Be prepared to handle basic questions and give truthful information. Misrepresentation of material fact is cause for disciplinary action by the Real Estate Commission. Now, you're going to be brand new. You're going to deal with buyer prospects that's going to want to see new construction. And the odds are they're going to ask you certain questions pertaining to new construction. And if you're not familiar with new construction or the construction processes and the stages that it goes through, it can kind of put you in an awkward position. What I recommend for all of you, anybody's brand new, even though we're going to learn some basic knowledge about construction until you get a handle on it, always remember you have an out, and that out is the builder. The actual builder or his representative. Remembering they want to sell their product. So if you have a buyer prospect who wants to see one of their products, call them. Make an appointment to meet them with you and your buyer. And let the builder walk with you and the buyer through the house, and let the builder answer the questions as you learn the knowledge. Always remember that safety valve for you. Okay? Be prepared to handle those basic questions, and always remember to give truthful information. We have different styles of construction. First one we're going to talk about is ranch. It's ranch style. One story, offers easy accessibility and the maintenance, but it's also the most expensive to build. Now, why do you think it would be the most expensive to build? Yes, sir.
Based on the fact that it's one level, you're having to spread the foundation further instead of stacking stories on top of each other going up.
Very good. The foundation and a roofing, we're going to learn in a minute, is the most expensive part of the construction. That footprint. The two-story obviously is a less of a footprint versus that one-story. Here's your two-story. Two-story offers twice the living area for the cost of the foundation and the roof. A little more profit margin in there, don't you agree? Mm-hmm. Two-story. We also have split level, also called a tri-level, where it takes its advantages of uneven terrain. Or obviously, the further north you get here in North Carolina, north of us, terrain gets a little more uneven, a little more rolly. Down here, we're kind of flat. We don't see too many of the tri-level or the split level down here, but we have a few. And they take advantage of that uneven terrain. We also have contemporary, usually a combination of the three, all right, elements of the three. Others include the Spanish, Cape Cod, and Georgian. Several of them available. Different types and styles. Now we get into the first stage of construction, that's the foundation. The footings, the basic components of the foundation is the footings. Again, as Tom mentioned, it's the footprint of the building. It's the lowest part of construction, the footings. foundation walls rest on top of the footings and provide a surface for which the flooring is built. We have piers in there, also called columns. May require support the foundation walls in case the spread's too far. Different types of components of the foundation: crawl space. We have some with the basement, some with a concrete slab. Footings, footprint of the building, lowest part of the construction, as I mentioned. Here's a picture of the footers. There you get a picture where they actually are digging out the dirt. And then they board it up and they put rebar in there, steel. This is prior to pouring the concrete. There's a picture of one right there. I'm going to give you a picture of another one here too. There's another one that's been dug out. Again, you can see where it's boarded. You get a closer view of the rebar, the steel, which helps hold it together. This is where they pour all the concrete in. Once all the concrete has dried and cured, those boards are going to be removed. Here's what it looks like. All that concrete. I do want you to pay attention in this slide as we move forward about this area right here. Let's just talk about those in just a second. Now the footers are in. What's the next stage of the process?
Foundation.
Foundation. Very good, Mike. The foundation. Foundation walls rest on top of the footings. Provide a surface which the flooring is built. That's the foundation walls. There's a picture of a couple of them. Here, concrete block. As you can see, it's concrete block has a brick outside for prettiness. And over here is one without the brick. It's concrete block. Take note of these right here. Anybody know what these might be?
Vents.
Mike says they're vents. Yes, ventilation. Why do you think it's, why we have it vented? Why?
Moisture. Moisture.
Moisture. Very good. That allows air to flow through there constant when the wind's moving. And so any moisture gets in there, dries it up. Without that, you end up with a sweat box in there. Foundation walls. Now the foundation walls are up. Again, I told you about that picture earlier. Here now is the piers that were built on those spots that you saw in that last picture. Piers. Also called columns. May be required to support the foundation wall. Why do you think we might need a pier in that picture here?
Prevent sagging and to support the foundation walls based off the length of the distance between the actual foundation walls.
Mike said on count to prevent sagging, extra support. Yes, yes, sir.
It ensures the structural integrity of the home.
Ensures structural integrity. The span coming across here, you'll see some other pictures in a minute. I'm not saying how far, but I'm saying is a builder's got codes to go by. They know when they got to put them in there as far as that extra support. May be required to support the foundation. Now, there is a picture of these piers here. As you can see, they're adding support. Now, major types of foundations, we know we have a crawl space, we have a basement possible, and a concrete slab. First one we're going to talk about is a crawl space. Here's a house that's built up off the ground. It's called a crawl space. Right here, the picture of it. It's built up off the ground. As you can see, all three pictures. Some people prefer houses built up off the ground. Some people prefer slabs. I guess it's a personal preference. There's pluses and minuses for either one. What would you think a added plus might be for a house that's being built on a crawl space versus a slab?
Access to utility lines, access to power lines.
Mike says access. What else?
Seems like if you would have issues with pipes or anything underneath the house, it'd be easier to, like, correct. I don't know how a
All right,
foundation
Samantha
slab
said,
works.
she said
My
access
house
to the
is crawl
pipes.
space, so
To the
that's-
pipes,
Yeah,
the plumbing,
yeah.
yes. Also, some of your crawl space houses, your air handler for your heating and air conditioning, a lot of them are put in the crawl space on a 2-story house, where a slab has your air handler up in the attic. There's nowhere else to put it. Crawl space. Now, also I want to mention in this crawl space, look in here, in this picture here,
Vapor barriers.
you'll see some plastic called vapor barriers. Vapor barrier allows, stops moisture from coming up through the ground, getting up to that wood, to those floor joists. Also, look back here. What do you see back on that wall there in that picture? Some weather stripping, some plastic. I'm going to show you another picture on the outside how they weatherproof and weather strip that building, that block. But there's a picture of on the inside. This here, what do you think this here might be?
That's your
Heating, air
AC.
conditioning vent.
Heating and air conditioning vent system. It goes from room to room from that air handler. Now, before they start building the foundation, now they got the footers in, what they're going to do is treat the soil. For new construction, they spray, as you can see in that picture, is chemical down. This chemical that they put down kills subterranean termites. And subterranean termite, that spray they put down, supposedly lasts for 30 years. Kills subterranean termite inspection. I'm not a termite. I'm just telling you what the warranty, 30 years. And you can see also in the other picture, they come around annually. Need be, they will keep on taking care of that piece of property and spray it. When a property is sold and there's a lender involved, for a fact with all government loans, but you also have conventional, but the majority of the lenders will require that the property be inspected for termites prior to approval of that loan. That's called a WDIR 100, Wood Destroying Insect Report. Every year, a homeowner pays a fee to keep his termite contract current. They come out, they inspect. If need be, they treat. In that contract they have, if there's damage done by termites, the company that's insured it, the pest control company, will have that repair done. That's what you're paying for your contract for. If you do not renew that service every year, you're going to find out from your sellers, if you happen to have a prospect who wants to sell his property, and you go out there and list it, and one of the questions you're going to ask, who is your current termite contract with? We don't have one. We've lived here 5 years, we never renewed it. Well, usually somewhere in the neighborhood of a little over $100 every year, the termite company comes out, inspects, and treats as necessary. If they let that policy elapse, each one of them has a different time frame, but somewhere in the neighborhood of a year and a half to 2 years, it has not been renewed. The seller wants to sell his property, they're going to have to do what they call a full-blown wood-destroying insect treatment on the property. I have seen them range from $600 to $1,600 to have it done. And if it's going to be sold, there's going to be a loan involved, it has to be paid, or we're not selling. They will actually come out and drill holes through the foundation of the house, through the sidewalks, through the patios, and they will backfill that in with poison, and then they seal up those holes. And that's, those holes they drill through that concrete, those foundation, it's there forever. You can't get rid of it. So, lesson learned here is when you sell a house, make sure your buyers, they receive that wood destroying insect report at closing, that you brief them on why it's important to have that inspection done every year. Years ago, for the ones of you that's in my age range, used to be a television commercial by Napa oil filters. Pay me a little now or pay me a whole lot later. That means you don't change your oil filter, which costs you $4 or $5 to change it. That's a little now. Or else when you need that motor replaced, give me a call. You pay me a whole lot later. Anyway, the wood destroying insect report. Now, back to the foundation. As I told you a while ago about the waterproofing. Here is an exterior picture of a concrete wall that's been put up, and on the outside they actually weatherproof that concrete with this sealant. And this will all be backfilled in with dirt after that's dried and sealed up. Actually waterproofing that foundation to keep water and moisture from getting in there. As we mentioned earlier, ventilation for your foundation. You have a vent every so many feet all the way around the house. I like to brief my customers about the importance of those ventilations, because some people in the wintertime that live up north come down here and they're used to blocking that off in the wintertime because cold air gets under their house and freezes the pipes. What happens, they close that up and they forget to open it back up. You come down here and close that up, you're going to have some problems if you don't get it back open. So I tell them it's made to be open. We don't have 20 below zero weather here. Ventilation, the foundations, very important.
Roger, do you know what that black stuff is? Is that a spray on?
The question is, what is that black stuff, Mike, correct?
Tom, yeah.
It's a waterproofing sealant they put down. It's, if you ever seen, it's like a tar base.
Yeah, okay.
It's like a tar.
Because you know that Line-X for your bed liners in your truck?
Uh-huh.
I heard they've started using that on the Pentagon because it is also a bomb blast protection because it doesn't come apart. Now, I don't think that would ventilate anything. I think that's for other reasons.
Right, that could be.
same spray, because it won't, if it explodes, the debris doesn't go everywhere and kill people,
Right.
Keeps it intact somehow.
Well, and it could be.
Yeah.
The main purpose of this one here is, so this one's for moisture.
Okay.
To keep the moisture out. Waterproofing and ventilation for your foundations. All right, next stage of construction is the framing. The sill. We're going to see some pictures here in just a second. The sill, lowest horizontal wooden part of construction. I'd remember that. The lowest part of the construction, the wooden construction, is the sill. Floor joists, that we're going to see pictures of, attached to the sills, 16 to 24-inch intervals, depends on what you're building. Girders rest on top of the piers. That's also part of the framing. And then the subflooring, sheets of plywood, press board, they lay on top of that, the flooring. Now we're going to talk about, first thing is the floor framing. As I mentioned, the sill, lowest part of the wooden construction. I got arrows pointing to that sill. That sill plate, when they build a house, that sill plate is pressure treated wood. It's not natural pine. It's treated. That's why it kind of looks like a different color. The purpose, anybody know the purpose of the pressure treated wood laying down on that concrete?
Rotting and testing.
Moisture.
Rotting, what else?
Moisture.
Moisture. What else? Another one?
Pest infestation.
Pests, termites. Pressure treated wood has gotten better now, but pressure treated wood has arsenic in it.
That's why you don't burn it.
That's why you don't burn it.
Yeah.
We used to have a lot of people that buy a brand new house and they collect all that wood up and have a nice big bonfire out there. pressure treated. Termites do not like it. That North Carolina pine is like steak. That pressure treated wood is like spinach. Pressure treated wood, the sill, the lowest part right here. Floor joists. They attach to the sills, 16 to 24 inches apart. As you can see, the floor joists right there. Pictures of them. Girders. They rest on top of the piers. Here's your piers you saw earlier in the pictures when the foundation was poured. Now, there's your pier. Now you're going to have a girder that comes across on it right here. That floor joist is going to sit on top of the girder. But the girders rest on top of the piers. Now this is framing. This is talking about a house that's built on a crawl space. Altogether different than a slab. We're going to see some pictures of a slab in a minute. Subflooring. Sheets of plywood or press board lay on top of the joists and the girders. You see pictures of them there being put down. Now that we have the foundation stage in, we have the flooring stage in, what we think the next stage will be? What's going to be going up? The walls. The walls. What's some types of walls that we have? Types of different walls.
Load bearing and non-load bearing.
Load bearing, non-load bearing. I'm sorry, Michelle, what'd you say?
Nothing.
We have interior, exterior walls. Interior walls are normally made of 2x4s. If you don't know about wood dimensions, a 2x4 is 2 inches wide, or thick, 2 inches thick, 4 inches wide, that's a 2x4. The last number, that's in inches, the last number is in feet. So if you had a 2x4 by 10, you would have a piece of wood that's 2 inches thick, 4 inches wide, and 10 feet high, or in length. We also have exterior walls that's made out of 2x6. 2x6. What would be the advantages, you think, of having a house constructed with 2x6 versus 2x4?
Stronger.
Stronger. Insulation. Holds more insulation. That's another one. Personal preference. Most of your builders will build a 2x4 house. If they get into building and promoting high energy efficient homes, one of the requirements needed to be considered a high energy efficient home would be a 2x6 exterior walls that hold more insulation. And we'll talk about insulation here shortly. Now back to this framing and the walls. Studs. Vertical lumber, spaced about 16 inches apart. Vertical lumber. We have a sole plate and a top plate where they connect. And we have headers, where we have 2 pieces of wood connected, adding extra support to the wall framing. So we got studs, sole and top connections, and headers. There's a picture of your studs here. You can see them going up 2x4s. We also have some of your commercial buildings that have steel or aluminum walls, not wood. As you can see a picture of them there. Wall framing, the studs. Vertical lumber spaced about 16 inches apart. When they measure a stud 16 inches apart, they measure from center to center. They will use the phrase 16-inch on center. So from the center of this one to the center of that one would be 16 inches, 16-inch on center. Some of the connections. Here is a top plate. So you can see a picture of it here. You got your walls up. The And then you're gonna have a piece of 2x4 coming all the way across. That's your top plate. Here's your another picture of it over here after the second floor is put up, right there. There's your top plate, your top connection.
I'm sorry, is that spray foam insulation?
I'm sorry?
On the picture to the left, is that spray foam insulation, or, I can't tell?
It looks like it's stuffed in there.
Oh, okay.
But if it is stuffed in there, what's wrong with it? It's backwards.
Yeah, probably, yeah.
But that could be a foam, I really can't tell.
Okay, I can't either.
We'll talk about the insulation here in a second. Back into the framing. Headers. 2 pieces connected, adding extra support to the wall framing. Anytime there's going to be a cut in a wall, where there's going to be a window or a door, anytime you cut into that wall, it's going to make a weak spot. To add that door and window, we're going to have a weak spot, so we got to do something to beef it up. And what they do is here, you'll see many, many 2x4s. Look like there's 5 of them right there. There'd be 5 over here. Over here, you see with this window, they have 2 and 2 versus 1. Then they have a header up here put across, sitting on top of those 2x4s, taking care of that weight. That cut we put in there made it weak. We're now going to beef it back up with that header. 2 pieces connecting, adding extra support to it. Roof framing, the next stage going up. Put the walls up, now we got to start talking about the roof framing. Ceiling joists. Attach the top plate of the wall and carry the weight of the roof. We also have rafters. Connect to the ceiling joists and the ridge boards. The ridge boards, I'd remember this, highest part of the construction. Ridge boards, highest part of construction. Those ceiling joists, as I talked about, attach the top plate of the wall and carry the weight of the roof. There's a picture of them right there with the arrow pointing to them. The ceiling joists. Now we go into more of the roof framing, the rafters. They connect to the ceiling joist and the ridge board. Here you can see where they connect to the rafter, and it connects to the ridge board here. Highest part of the construction. There's a picture of your ridge board and 2 pictures. Right where the arrow points. Here's some pictures now of the different types of roofs that we use and have. You'll see the gable, the gabriel, the hip, the flat, salt box, and mansard. Different types. Major roof designs. Now we're going to talk about the truss system. When a house is being built, the builder has, there's a lot of preferences here, and the buyer too. If it's a pre-sale and a buyer is specifically asking for certain things to be built and altered, those things are kind of considered a custom build. They're building outside the norm of the plans, they're altering them. When all of you have seen it, you haven't paid much attention to it probably, big old flatbed semi running down the road. They got these huge pieces of whatever, flat, stacked up on top of that flatbed truck hanging over, and they look kind of weird shaped. Those are rafters being delivered to a house that's being built. Rafters can be, trusses can be built on site, or they can be ordered. The pictures you have in front of you, and I'm going to show you in just a second, show you how they build those off-site and deliver them and be put right up. The builder also can build them on-site, cut them, put them together. These for example, right here. It's an alternative way. They don't use ceiling joists, rafters, or ridge boards. They're prefabricated. They're actually put together in a factory and using these metal full of teeth. They lay it down there, hit it with a hammer and a piece of wood and slam it in there, and it holds these pieces of wood together in all these points on both sides. Lay it on a flatbed truck, 18 of them, and deliver them. It's an alternative way versus building that piece by piece by piece, cutting and putting it together on site. Roof truss system. Now we're going to talk about the eaves. The overhang of the roof, which is made up of soffit, frieze board, and fascia. You can see pictures of it there hanging over. Gutters are usually attached to the fascia board for houses that have gutters. The overhang, the eaves. Why do you think we have an eave? Why do we have an overhang like that?
Protect the sides of the home from weather damage, water runoff.
Protect the house from runoff, water, rain. When the water comes down, if you see sometimes, you'll see some of these older houses that don't have much of a overhang. And the water will actually run right down, almost down the side of the house. You'll see it come off the window all the way to the ground. You got one of those.
My house was built in the 40s, it's barely.
Yeah,
Protect the foundation, actually,
you
right?
did that too. Protects the foundation.
What the-
You put that over, you have the eave over, the water's gonna fall a couple feet from the house.
How attractive do they look though?
How attractive are these?
No, you're out.
Just about every house has an eave.
Overhang?
You better go look at it.
A little bit, I got a
you
small
better
one,
some?
but ain't much.
You got one though, right?
Now let's talk about this for a second, this overhang.
Christmas lights.
Number one, it hangs over from the side of the house. And we know that's going to make the water fall a couple feet from the house. The purpose of gutters is not necessarily just to make it look pretty. Gutters move water to certain spots of where you want it to go. We talked about the foundation a while ago. And the waterproofing, the water sealing, the moisture barrier that Tom mentioned down there. You get a house that doesn't have an overhang, like Samantha was talking about, water runs down there constant over the years. A house with no gutters. It's just a matter of time before that water is going to saturate that ground and then come right back up through on the other side of that wall or start deteriorating that waterproofing because it's constant. Once you get moisture under the house, we just had one here last week in this office, last week, where they're looking for somebody to go out and attempt to get the moisture out from underneath that house because the termite people will not pass it to be sold because there's too much moisture. The moisture level is too high under the house. And it will rot and put mold and mildew on the joists.
Should have called me, I got a pump.
Should have called you, got a pump. Well, the overhang, the eaves, and the gutters are going to direct water to, in most cases, to two spots on the front of the house, let's say, or the back of the house. One or two or three spots. From that point where they come down, now you can use PVC pipe or whatever to direct that water out away from your house. A lot of them will put the perforated pipe underground, full of holes, let the water run underground away from the house and then soak into the ground out there. Others will use one on top of the ground to get it away from the house. The point being, the purpose of the eave is to protect the house. And as you mentioned, Samantha, you don't have one.
Oh, there's,
You got a 2-inch one.
yeah.
And you do get water running down the side of your house when it rains hard.
Mostly in the front, yeah.
Okay. All right, next stage. The exterior walls. They're up now. We got sheathing that's going to be added to the wall framing to help insulate the house. We have different types of sheathing. Particle board, foam sheathing, plywood, or tar paper. The one you see in that picture is plywood. After the plywood is put up, they will put a wrap around the house. A lot of them say Trevec. You'll see it. They'll wrap that house up and seal it from moisture and water getting in there. If there was a leak somewhere, that also adds protection to help keep that water from that leak from getting into that house. Some of the houses you'll see, they have that white Trevec wrap. Others will wrap in tar paper. Felt paper it's called. They will actually wrap it, just like they do on a roof when they put the roof down. It's to help insulate. Siding. We have different types of siding we use in North Carolina. We have wood siding, cement, brick, vinyl, stucco, aluminum, concrete siding, hardy board. Many, many, many types of siding. Next stage is the windows and doors. Different types of windows. We have sliding windows, double hung windows, horizontal, swinging windows. We also have fixed. A fixed window would be like a bay window. Everybody here knows what a bay window is. We have different types of doors we use, interior and exterior. You have flush doors, panel doors. There's a flush door right there. Paneled. We have sliding doors, French doors. We have some that's solid wood. And you have some that's just got some cardboard in between. It's real thin. Versus the solid ones, it's solid wood, for example. You peck on them and find out the difference. Different types of doors. Some of the major components of the window and door framing. You got a picture there in your slide. You have the jamb, which is the side. You have the header, it's the top of the framing. The sill is the bottom. Window sill. In the window, the glass panel that moves is called the sash. I remember these two here. Muttons are the horizontal pieces in those pane windows. Mullions are the vertical pieces. Muttons are the horizontal, mullions are the vertical pieces in the window.
I've never heard those two words in my life.
Now you have.
Yes.
First time for everything.
Yeah.
That's why we're here, learn the basics. Now let's move on into the roofing part. Sheathing. On top of that roof, usually made of plywood or material similar to wall sheathing. They put that sheathing down, that plywood down, then there comes your roofing felt paper, your tar paper. Comes on top of it. Then they put the shingles on. Shingles we have here made of asphalt or fiberglass. We also have wood roofs, built up roofs. You could even possibly see tile roofs, very expensive, slate tile.
And aluminum.
Aluminum roofs, yeah.
Aluminum, very good, yes. The metal roofs they call now, the red, the greens. People like to hear the rainfall. Supposedly those metal roofs have a lifetime warranty. When you buy shingles, you can buy shingles for 20-year or 30-year warranty. Made of asphalt and fiberglass. Now, we have a roof pitch of the roof. It's measured by the number of inches of rise per foot. If you had a roof, per se, that what they call a 2 by 12, that means every 12 inches of distance, the pitch of this roof is going to rise 2 inches. 2 inches. You go another 12, 2 inches. 12, 2 inches. 12, 2 inches. 212, 2 inch for every foot you measure. You have 4 12s, 6 12s, which become very steep. The pitch, measured by the number of inches of rise per foot of horizontal distance. Next stage, insulation. We have bats, we have blankets or loose fill. We also have sprayed in foam. When you see a house being built, you'll see the insulation, some pictures of the insulation. And one side is the actual fiberglass looking insulation. On the other side is a paper. And on that fiberglass side, they will put plastic up inside that wall. Then they will stick the fiberglass roll and roll it out between those 2x4s, cut it and roll it in there, and take the paper and staple it to the 2x4s. So you're seeing paper, insulation, and then waterproofing on the other side. The weather stripping is in there. They have loose fill. They can come in like in an attic. They will go up in your crawl space. They have this machine leads out to a truck. It's full of this big tube. Truck is full of this loose insulation, and this machine that pumps it. They go up in your attic and actually spray the insulation to be so thick into the ceiling and fill all that in. That's another type. Then you have foam, as we saw maybe in that one picture where they spray that foam up in there. R values of the insulation. The higher the number, the more resistant the material is to the transfer of heat. For example, in North Carolina, the minimum for a wall is R13. The minimum is R30, and your floors are R19. These are the minimum standards for building a house in North Carolina. The majority of your new construction are built by the minimal standards, unless the buyer requests it to be higher, and of course there'll be more cost. Any questions about that? Yes, sir.
You might have said it, forgive me. R value, what's the R stand for?
The floor is resistant of the heat.
Okay.
The higher number, the more resistant the material is to the transfer of heat.
Okay, thank you.
Weather stripping and moisture control. As we talked a while ago about that picture of the house where the outside wall was sealed up. We also talked about the inside of the wall where we saw the plastic put inside that crawl space when we looked at the pictures of the moisture barrier. We also talked about the insulation being put up, and behind that the weather stripping. When your doors and windows, you also have weather stripping put in before they actually put the doors and windows in. They actually put that stripping in there, and then they will put the window in, for example, and then they'll spray the foam insulation in between those gaps. Moisture control is the vapor barriers that we talked about and saw pictures of. Also up in your attic. Go home tonight and look at your house, the side of your house. You'll see some sort of opening on the side of your house up toward the top. Some of the houses you may not see that. But if you look on top of the ridge board, the very highest peak of your roof, you're going to see a shingle base running down through there that doesn't look quite like your house. It kind of looks like a little house sitting on a house. I'm sorry?
Like a hip.
Yes. And what happens, what that is, there's a rise where those two pieces of plywood come together before they even put your shingles down. There's a little gap there. That gap is there on purpose to get air in and out of there. So they may put this board, this ridge of shingles, special made, all the way down through there that sit this high up, and they have like vent systems in them where the air can flow through there. And then on the side of your house, you've got holes on the side of your house, vented system. The air can flow in and out, constantly moving that air around. If you seal your roof up tight with nothing, you're going to have a moisture nightmare. Yes, sir.
So where they meet right here, if you look at your roof, and I haven't been up on it, but the shingles where these two pieces just about meet, instead of being, you know, like this, they kind of go like this, and they look like there's a small gap on each side.
Yeah.
Is that what that is?
Yeah, and you think, my gosh,
Okay.
water's gonna get in there.
Yeah, okay, that's what that is.
Yeah.
It's a little plastic triangle vent that runs over
And you
every
go, why?
2-inch opening.
Yeah,
You think water's gonna run right in there, but it doesn't. That water's gonna have to flow that direction.
it
up
won't
through-
go that way, right?
Yeah, to get up through there.
Okay.
Vapor barriers and attic ventilation. Next thing we want to talk about, heating systems. In North Carolina, we have different power sources. Obviously, we have the sun. We also have gas, oil, electricity, coal, and wood. These are all power sources. The methods we use for heating, we have solar, warm air, hot water, steam, electric wire they call it, using electricity. When I was little, the house that I was raised in, the power source was coal in a furnace in a basement in Indiana. There was no, it had a ducting system that led to every room, but there was no fan. It just, my father put the coal in there and heated it up, and the heat would rise through, because the heat rises, it goes through the vents to all the rooms and the heat comes out. Then the other one, as far as the forced air, you put a fan in there. Instead of waiting for it to get up there, it just blows it up there faster. Different ways of heating. There is a method I was talking about as far as the air. Gravity warm air, no duct system or fan, just rises. You have central forced warm air where you put a system in with vents and a fan. Space heater. I don't think anybody in this room doesn't know what a space heater is. Kind of dangerous, space heaters.
Yeah.
Some of the subdivisions, some of the houses around here, even here, we have solar heat. Solar panels. And we have electric baseboard heat also. Now, air conditioning. Central forced air. We also have room air conditioners. We have a combination of heating and air conditioning. The majority of systems we have here is heat pumps. The heat pump system is a very high energy efficient way of removing moisture out of a building and replacing it with cool air, for example, for air conditioning. People that come out of above the Mason-Dixon line, it's used to the below zero weather, when they have what they call central heat. When they turn their heat on, it's like turning electric heat. It's like turning the oven on of your range. Those coils light up and glow, and a fan blows air across it and heats your house. Kind of expensive, but that's heat. Down here, we don't have that severe cold weather, so the heat pump works very well for us, where we can save money by heating up a room over time by removing the cool or the moist air out of the room and replacing it with dry, warmer air. That's basically what a heat pump system does. But the problem we have educating our consumers down here is about the heat pump. It takes some time. Up north, you turn the heat on, boom. Down here, you turn the heat on, you don't like it. Well, in most cases, you can have the ability to override it. Meaning, if you crank it up 3 or 4 degrees above what the temperature is now, this little light comes on. green or red light. If you look at closely on the dial, it says EMG period heat. Emergency heat. I'm cold, I want warm now. You move it 3 or 4 degrees past where it is, that light comes on, go look at your meter outside. It's just spinning.
Oh, yeah.
Because that's just like lighting up the range.
Yeah.
You override the heat pump system, it'll give you some instant heat. Where if you move it up 2 or 3 degrees, say it's 68 in here and I want 70. Well, instead of just taking it and shoving it over to 90 and get me up real quick, just move it up to 70 and wait a little while. It will finally get there, and it will do it very efficiently. And then if you want a little more, take a little more. They will also tell you with the heat pump systems, set it to where you like it and leave it alone. Let it maintain it. Because if you let it drop back down or get way back up, it takes a while for it to even back out. Where it can stay where you want it and be very efficient. Air conditioning. Again, central forced air, room air conditioners, and then we have the heat pump. North Carolina. Building codes. We have building codes. Building codes every year change for the better. They find things they can make better. You need to remember, you think about that, the house was built in 2000, I'm just picking a year, 11. 2011 up to code. Now it's time for me to sell, it's 2016. And there have been 5 changes in the building codes since I had my house built. Is my house built to code?
No, but is there a grandfather
Built
law?
code, yes.
It was built to code in 2011. There's nothing wrong with that. What happens is, if, I'm giving you an example, if there was a major change in the way we do electrical wiring, and it was put into play as a law, as a code, to be built from now on, it would never apply to me in 2011 unless I made a major construction change to my property, i.e. a room addition. It's going to have to be built to code. What might happen is that electrical box that's running my house is 2011's. This new one for 2016, I'm going to have a different box and a different wiring system for that room addition, because it's got to be built to code. But my house is not out of code. Okay? That's a good question that comes up a lot, especially first-time home buyers, and they get a home inspection done, and the home inspector says, well, this thing was built in the 50s, it's out of code. What's wrong with it? He's letting them know things have changed since 1950. The HUD has minimal standards. The HUD. A builder wants to build a product. HUD standards may be a little bit stricter than what the building codes are. If he wants to sell his product under the HUD standards, which your government loans are going to fall under, he has to build them according to that, i.e. VA. A VA loan. They want a house built to HUD standards. So they have special requirements. The builder has a copy of those requirements, and he has to be approved to build those homes according to those standards. If someone is going to be hired to do some sort of repairs or construction to a piece of property and building, the cost is $30,000 or higher. That person that's being employed has to be a licensed contractor or have a licensed contractor on site with them. $30,000 or higher. If somebody's going to be employed, and he says the bid's $35,000, there has to be a contractor involved.
Now, if an owner is going to do an addition,
Owner
that's
is-
gonna exceed the cost of $30,000, is he allowed to perform that addition on his own without a contractor?
Yes,
As long as he doesn't hire anyone to perform any type of services
correct.
to build that
The
addition.
question was, homeowner, say it's 35,000, can a homeowner do it without a licensed contractor? Sure he can. Remember though, the code, the permits, they're gonna be out there inspecting to make sure it's done correct way. The contractor is, if I'm getting paid, you're gonna pay me, I've gotta have a contractor in here liable for this. You as a homeowner, you're liable. You're gonna do it on your own.
Right.
That's a good question though, it comes up a lot.
What was the question again?
Did you get it? You want me to say it again?
Wait, one more time.
One more time.
One more time.
If you are a homeowner
Right,
and you wanna hire me to put a room addition on your property,
right.
and my bid is $35,000, it's above 30,000, and you say, okay, I will use you. Well, I have to have, either I'm a licensed contractor, or I gotta bring a licensed contractor in to oversee the job during this process. If you're the home builder, you don't want me,
Right.
and you get a bid for $35,000 and you're gonna do it yourself. You get your permits, you start building, there's gonna be inspections, you don't need a licensed contractor,
Okay.
because you're liable for yourself.
As long as the permits
Your
and
house,
code.
it's your issues, if something goes down.
Right.
Yeah, that cleared up a lot of confusion to me, because I was stuck on that $30,000.
Right,
I was
$30,000.
required to get a general contractor.
But if you.
You own the home, it's your liability.
Now, the last thing I want to talk about in this chapter is modular homes. Modular homes. If you go down Highway 24 towards Swansboro, there's a modular home dealer down there on the left. The difference between modular homes and stick-built, that's what we call stick-built, what the builder builds. The wood is delivered on site. The builder and all of his subcontractors put this whole, pick it all up and put it together. Where a modular home, the wood is delivered inside this huge building, climate-controlled building, wood's delivered. Subcontractors are hired to come in controlled temperature building and put together walls, roofs, whatever they got to do for this house. And then all those parts are loaded on a truck. Wherever it's going to be delivered, the foundation has already been poured. Footers are in, everything's ready to go. The truck pulls up, some subcontractors are there. They'll start taking it off one piece at a time and putting it up. The only difference is one is built outside in the weather, and one is built inside in climate-controlled atmosphere. Now, firsthand, I can tell you, when I built my house, 2005, we had 2 hurricanes while I built that house. And I remember sitting in my camper looking outside as a hurricane went through and seeing all my wood out there, the plastic blown off and the wood soaking wet. 36 hours later, here comes a subcontractor, start putting walls and stuff up. Where a modular is built indoors, it's a personal preference. Where one is put together inside, one is put together outside.
Is the modular home more expensive?
No, they're cheaper, that's
They're
what.
cheaper?
Yeah,
I'm just.
yeah.
The question was,
In the climate home.
is it more expensive?
Right,
I guess it depends on what you get. You have to do some shopping compared to what you're looking for.
right.
But I didn't want you to know there is a difference where they're being built and how they're delivered. Up north, you have a lot of that, a lot of modular. Because the weather's so adverse in the wintertime.
You have to do it.
You can't get them out there to put the house up. Yes, sir.
Am I wrong, aren't they generally cheaper?
I've never personally shopped for
Me
one.
either, I just,
Well, don't you usually have to purchase land with it?
well, yeah, you
Well, you gotta have some
lot.
land, yeah.
Yeah.
You gotta put it
So
somewhere.
that cost maybe.
You have to have actual
But
foundation.
you're not even allowed to put one of those up where I live, for some reason.
Well, yeah, there's restrictions.
Yeah.
There's some subdivisions won't allow it.
Yeah,
Manufactured modular, they can't go in there.
no, no.
Well, up north, they're very common.
We have discussed chapter 15. Before we take our break, any final questions about chapter 15? 16, I'm sorry.
That's okay.
16, basic residential construction. All right, take a break.
All right, that was fun, that's cool stuff.